Right, let's recall what we've done in this block. We've looked at lazy evaluation, the approach that says only compute what you need, only once, only when you need it. And we've seen how this leads to a different kind of approach to programming in a language like Haskell. We've seen that we can do data-driven programming where instead of worrying about building intermediate lists, we see that those lists are only built on demand and so perhaps never built fully, so that we can write high-level programs manipulating lists without worrying about being inefficient with space. And then we've seen other approaches come in which are quite novel because of lazy evaluation. We can think of having infinite lists in the language. We can think of computing with streams of values. And we saw some interesting approaches there where we get efficient solutions to problems when we think of building lists as streams. We solved an example of a search problem, route finding in a maze, using a lazy approach that says describe the set of all the possible solutions. Then if you just want one, just compute the head. And computing the head can be way more efficient than computing all the solutions. The solutions are just computed on demand. We also looked at efficiency of fold R, fold L, and we found that for a strict operation like plus, where strict, I mean, it needs both its arguments to be evaluated, neither of them does a particularly good job, and that we need a strict variant of fold L called fold L prime, which ensures that the value we're carrying along is always evaluated, fully evaluated as we compute. And I remind you, there's another case study in the book in section 17.5 of how you take an approach to parsing using, using lazy evaluation. And take a look there if you like.